So this is part 2 of the 4.2 trig functions video. We already went through these slides. So I am going to do another example of regular evaluating trig functions using the unit circle. And now here we are going to do all 6 of the trig functions. So in the last video, I only did sine, cosine, and tangent, but now we're going to do all 6, which include the reciprocal functions. So when we do this, the first step is always to find this value on the unit circle and to get the point that goes with it. So I would have your unit circle handy, and here I have my unit circle. So I go around the radians, and here is 7 pi over 6. So this is the coordinate point that goes with 7 pi over 6. Negative square root 3 over 2, negative 1/2. So now what I'm going to do is I'm going to set up sine theta, cosine theta, and tan theta. So keep in mind, you always want to write this symbol theta, which matches this. This is saying sine of this angle, or you could write sine of 7 pi over 6 if you wanted to, and write 7 pi over 6 in all of these. Either way. So either that, or you could say tan of 7 pi over 6. And tan of 7, cosine of pi over 6, and so on. But for now, I'm just going to keep everything the same and just use theta. So it's just saying trig function of an angle. And the angle is 7 pi over 6, which is down here. So now using these, we have to think of our rules of x and y. So this is x, and this is y. Sine goes with the x value. So sine of theta is negative 1/2. The x value goes with cosine of theta. So cosine is negative square root of 3 over 2. And the tan of theta is equal to y over x. So I always like to think of it just the top one over the bottom one. So this is negative 1/2 over negative square root 3 over 2. So now I have to divide. Negative 1/2 times, and I'm going to flip this bottom one, 2 over this negative square root 3. So since I have a double negative, tangent is going to become positive. And here I have a 2 on top and a 2 on bottom, so I'm left with negative 1. Nope, not negative because there was a double negative. So positive 1 over the square root of 3. Now, because I have this over the square root of 3, we need to what we call rationalize the denominator. So get the square root out of the denominator. So in a different color, I am going to show how if you multiply this by square root of 3 over square root of 3, so because it's the same number over itself, that's 1, we're not changing it, this will equal square root of 3 over the square root of 9, and the square root of 9 is 3. So I'm going to write that as 3. So the square root of 3 over 3. So that is my tangent value. So this is the same thing as this. This is written in simplest form. So now I'm going to go through and write my reciprocal functions. I'm going to erase a couple things so that I'm able to do this with some space. So if I want to now find cosecant of theta, and I always like to set it up like this with whatever is the reciprocal right next to it. So sine is negative 1/2. Cosecant is negative 2 over 1, which equals negative 2. Cosine theta equals negative square root 3 over 2. So secant theta equals negative 2 over the square root of 3. So once again, just like we had here, we have to multiply the top and bottom by square root of 3 over 3. And here we get -2 over the square root of 9 and the square root of 9, -2 square root 3. Sorry, so we have -2 times the square root of 3, so -2 square root 3 over the square root of 9 is 3. So we're going to write that as 3 on the bottom because you never want a square root in the denominator. So I have -2 here, and I'm just going to box in my answers. Now, tangent goes with cotangent. There's not a lot of room over here, so I'm going to put it down here. Cotangent of theta equals. Now, keep in mind, this and this are the same thing. If we flip this version of tangent, we're going to get a square root in the denominator. So if we flip this version, we will not, because we get the square root of 3 over 1. So that is y, which is square root of 3. It is important to know that after you rationalize the denominator, these two values are the same, just one is written in standard form, but you might want to keep one already written on your paper so that when you go to do cotangent, you don't have to get rid of the square root in the denominator again. All right, and it looks a little chaotic, but here I have sine is -1/2, cosine is negative square root 3 over 2, tangent square root 3 over 3, cosecant is -2, secant -2 square root 3 over 3, and cotangent is the square root of 3. So now we're going to do the same thing for pi. So pi, if we find that on our unit circle, is right here. -1, 0 is the point. Let me get rid of this stuff. All right, so I set these up for us. So since we want all 6 trig functions, I have 1, 2, 3, 4, 5, 6. I like to set it up this way every time, having the reciprocals right next to each other because it just makes it easier, and then having sine, cosine, and tangent all in a row like this. So sine always goes with the y value, so this is my y value, which is 0. Cosine always goes with the x value, so it equals -1. Tangent goes with sine over cosine, or y divided by x. So 0 over -1 equals 0. So 0 over a number is 0. If you have a number divided by 0, that's undefined. Now cosecant, you flip 0 over 1, so it becomes 1 over 0, which equals undefined. So undefined. Secant is 1 over -1, which equals -1. And then cotangent is 1 over 0, which equals undefined. So sometimes, cosecant is undefined as well as cotangent. Sometimes that happens. And that is how you evaluate using the unit circle. Now we are going to move on. What happens if you have a negative number? Well, if you have a negative number, something is going to, it's going to be a little different. So what we are going to do, because this is not on the unit circle, we are going to add 2 pi to start. Now I'm going to put it over 1 because we're dealing with fractions. So now we don't have a common denominator. So to get a common denominator, multiply top and bottom to get a common denominator. So this becomes 12 pi over 6. So when I add -6 plus 12 pi over 6, I get 11 pi over 6. That value is the same thing as negative pi over 6, and it is on the unit circle. So if you think about it, that makes sense. If this is up pi over 6, this would be down pi over 6. And now we're going to use this coordinate point to solve this problem. So we're using this one. And so for t equals negative square root 3 over 2, now it says just evaluate sine, cosine, and tangent. So we just need sine of t, cosine of t, and tan of t. So sine is y, -1/2. Cosine is x, square root of 3 over 2. And tangent is y divided by x. So this is -1/2 divided by the square root of 3 over 2, which is the same thing as -1/2 times 2 over square root 3. So we get -1 over square root of 3. So now, once again, we have to rationalize the denominator, and I'm now doing this on my unit circle. Just bear with me. So we end up getting the square root negative square root of 3 over 3 as our final answer. We can do the same thing for negative pi over 4. So once again, it's a negative, so we have to add 2 pi. So plus 2 pi over 1. And when we add 2 pi over 1, that does not have a common denominator. You multiply by 4 over 4, and you get 8 pi over 4. So negative pi over 4 plus 8 pi over 4 gives me 7 pi over 4, which is here. So we're going to use this point. So sine of t equals the y value, negative square root 2 over 2. Cosine of t equals the x value, which is positive square root 2 over 2. Tangent of t equals negative square root 2 over 2 divided by square root 2 over 2, which is the same thing as negative square root 2 over 2 times 2 over square root 2. Everything cancels, so we're left with -1. So keep in mind here, because it only said to evaluate sine, cosine, and tangent, we only do 3. We don't do all 6 like it was on the last example. Okay, so the last thing here, the period of the sine and cosine function. So a periodic function are functions that behave in a repetitive or cyclic manner. So it means we're going around in a circle. So we saw that when we added or subtracted 2 pi, you can do that as many times as you want. So the period is always 2 pi. And that comes from that being one full cycle. So if you add or subtract 2 pi, you land on the same point. We just saw that in the last example. But we're going to use that if we have a number that is maybe too big. So 13 pi over 6. Here, instead of adding 2 pi like we did for the negatives, we are going to subtract 2 pi. So your first step is add or subtract 2 pi until you get a number on the unit circle. So here we have 13 pi over 6. We're going to subtract 2 pi over 1. We need a common denominator. Multiply by 6 over 6. We get 12 pi over 6. Okay, so 13 pi over 6 minus 12 pi over 6 equals 1 pi over 6. So 1 pi over 6 is the same thing as 13 pi over 6. Now here it says evaluate sine of this. So sine of that is the y value at pi over 6. And now I don't have my unit circle, so we'll go back here. Pi over 6 is right here. The y value is 1/2. So that means that sine of 13 pi over 6 equals 1/2. Because it is the same thing as pi over 6. All right, and the last thing for this video, I'm going to put on the camera because we are going to be using our either graphing calculator, or you can use your calculator, your phone calculator. So evaluating radian measure on the calculator is different than when you plug in something in degree mode. So if you have a graphing calculator, you press mode, and this type of screen will come up right here. And you want radian to be highlighted in black anytime you're evaluating something in radian. So what does that mean? So if it says sine of 2 pi over 3, because we have pi in there, we don't have a degree symbol. That means we need to be in radian mode. So on your graphing calculator, this would be highlighted in black. When you click on mode, you want to scroll down, click enter on this so it is black. Right now it probably is highlighted on degree. On your phone calculator, so once again, you have to turn it this way, there is a button down at the bottom here that says rad. So when you click on that, you'll see that rad also comes up here. And then you can click it back to degree and then it doesn't say anything. So once you hit rad, then you're in radian mode and you can type it in. So like here for 2 pi over 3, you click 2, there's a pi button down at the bottom here. And then divided by 3, you can press equals, and then you press the sine button. And it should give you 0.866. For cotangent of 1.25. So it's still in radian mode. It won't change until you change it back. So you type in 1.25. Keep in mind, cotangent is the same as 1 divided by tangent of 1.25. So the tangent of 1.25 is 3.00956 and so on. So then we do 1 divided by that. Should get 0.332. And then the last one, cosine of 3 pi over 8. So 3 pi divided by 8. Yeah. 3 times pi divided by 8. We get 1.17. And cosine of that is 0.383. And I just want to go back and check because before I didn't do times pi. So 2 times pi for the first one. Okay, I guess it did work. All right, so that's it. If you have questions, feel free to email me.